Alright, so let's say we have these two patterns, right? Let's say we've got these two series. So remember, there's a difference between a sequence and a series. This is a sequence, while this is a series. So they're both the same, but the difference is that this has got commas between, this one has got additions between, right? And if you see negatives between, let's say you see a negative and negative, it's still addition, it's just that we're adding a negative. So for instance, we could have written it like this. But you see, to simplify it, positive times negative is negative. That's why we have this. And okay, that's why we have this stuff. Let me just use another marker. So we could have written it like this. We could have said 2 plus negative 4 plus 2 okay, plus what? Plus negative 8. So I could have done this, right? But then to simplify it, we could just say positive times negative, which is negative. So, and then here positive times negative, which is negative. So that's why we have negatives. So if you've got negatives, we're just adding a negative. So it's still a series. So this is a series, so I'm not calling it a sequence, I'm calling it a series because there's addition signs between them. So I'm going to show you the difference between converging and diverging series. So let's look at a pattern. For instance, let's look at this one. Let's just find out which series A, what's the sum of one term. Well, the sum of one term is just the first term, so it's 2. The sum of two terms, which is 2 plus 4, it's actually 6. And then the sum of three terms, which is 6 plus 8, which is 14. The sum of four terms, which is 14 plus 16, because it's just this whole stuff plus 16, which is 30. The sum of 5 terms, which is 30 plus 32, which is 62. The sum of 6 terms, which is going to be this whole stuff, which added up to 62 plus 64, so that's going to be 126. So if you notice this stuff, it just keeps getting bigger, right? It keeps getting bigger. So if I add another one, it will still get bigger. So there's no specific limit. It will just keep getting bigger and bigger and bigger, right? So the more I keep adding, the more it gets bigger. As you see, it keeps getting bigger. So this is what I call diverging sequence, right? So it keeps getting bigger. So this was the pattern. So it keeps getting bigger, right? When I check out the sum of one times, not that you'll be doing this in school, right? This is just for understanding. I want to explain to you the difference between converging sequence and a diverging sequence. So I want you to have core understanding of it. So here, this is diverging. Why does it diverge? It has no certain limit. It keeps on getting bigger. There's no boundary. It just keeps getting bigger with no restrictions. So let's check sequence B. So the sum of one term, okay, let me just use the other one. Okay, so the sum of one term is just half. Half is 0.5. The sum of two terms is half plus that part, so this is going to be 0.75. That's the sum of two terms. The sum of three terms, let me just check that in the calculator. So we're going to have so that's going to give you 0.875. Then let's check out the sum of four terms. So we have 0.9375. Then let's check out the sum of five terms. So it's 0.968. 1.875. The sum of 6 terms so it is 0.984375. Alright, so let me just add one more. The next term after 1 over 64, it's 1 over 128. So the sum of 7 terms is, so plus 1 over 128. So it's going to be 0.99. To just continues, right? So like it continues. Let me just write it all. So it's 2, then it's 1875. So 1875. So if you look at the pattern here, notice it never even went beyond 1. What's going on here? It's 0 point this, 0 point this. So if you look at it, it's 0.5. So the first decimal place starts increasing. So the first decimal place was 5, then it started increasing. It became 9. When it becomes 9, the second decimal place starts growing. It was 5, 7, 3. Then, okay, of course, this was before the first decimal place became 9. So when the decimal place became 9, the second decimal place was 3. Now it becomes 6, becomes 8. Then finally it becomes 9. When this becomes 9, the third decimal place will start increasing until eventually the third decimal place will also become a 9. Then the same thing happens to the fourth decimal place until it becomes a 9. So as you keep going further, 9s keeps being added, right? So it will be 0.999. When you continue going, it's still 0.9999. Then until when you do it infinitely, you'll finally reach 1. But of course we cannot do that practically, but if you could do that, we'll eventually reach a 1. So there's a limit. The limit here is 1, right? So the boundary is 1, so it never passes 1. Matter of fact, it never reaches 1 except if we reach infinity. That's when it will reach 1. So 1 is the boundary. So this pattern converges. So converging series means it has a certain limit, while it's diverging means it does not have a limit. It will keep getting bigger with no restriction. Matter of fact, the limit will be infinity. That's diverging. So converging means there's a certain limit. When we keep adding them, there's a limit. It will reach its limit. So that's a converging sequence. So that's the difference between converging and diverging. Converging, it has a certain limit. Diverging, it does not have a certain limit. Now the limit is what we call sum to infinity. So when a sequence converges, it has got a sum to infinity. Sum to infinity just means if we add this infinitely, we will get a specific answer. While it's diverging, if we add them infinitely, well, it will keep getting bigger, so it's infinity. And infinity is not a number. So converging sum to infinity exists. Diverging sum to infinity does not exist, right? There's no limit. While it's converging, it has a limit. It has a sum to infinity. So let's look at this. So let's look at something. Let's check an example. So we cannot find the sum to infinity of this, right? Because it was diverging of sequence A. Now let's look at the sum. Let's find the sum to infinity of sequence B or series B. So sum to infinity is always for geometric. If you hear sum to infinity, automatically it's geometric. So the sum to infinity is represented by this formula, a over 1 minus r. So, and notice it has got r instead of d because it's geometric. It's always geometric. So our a here in this case, which is 1 over 2 all over 1 minus our r. If you say 1 over 4 divided by 1 over 2, we will get 2. Right? Also, if you say 1 over 8 divided by 1 over 4, we'll still get 2. So we just get our a. Our a was 1 over 2. Our r was actually 2. So we just substitute it. Then we plug this in the calculator. If you plug this in the calculator, you will have the sum to infinity. I noticed something fishy here. So our r was not 2. When we say 1 over 4 divided by 1 over 2, it's actually 1 over 2. So our r is 1 over 2. Also 1 over 8 divided by 1 over 4 is 1 over 2. Alright. So our a is 1 over 2, and our r is also 1 over 2. So if we say 1 minus 1 over 2, I'm using my brain, you can just type this in the calculator and get your answer. Now if I say 1 minus 1 over 2, it's 1 over 2, and then 1 over 2 divided by 1 over 2 is 1. You can just type this in the calculator and the calculator will give you 1. So there we have it. We have our limit as I've shown. It's 1. So the sum to infinity is that specific limit when you keep adding these numbers. So our sum to infinity here in this case is 1. So there we have it, sum to infinity. So sum to infinity is like the easiest thing to find, right? So if you ask for sum to infinity in patterns, you just literally substitute. You use your formula and you find out what is your a, what is your r, and you just substitute, and this is how you get it. So sum to infinity. So it only exists for geometric, right? It doesn't exist for arithmetic. If I go a little bit beyond the syllabus, if we look at this 0 plus 0 plus 0, okay, it's not really beyond. This is an arithmetic and a geometric series at the same time, because the common ratio can be 0, so 0 times 0 is still 0. I can also say the common difference is 0, 0 plus 0, so it's still 0. So this is an arithmetic and a geometric series. Now this has a sum to infinity which is just 0, right? The limit is still 0. So in this case, arithmetic series has got a sum to infinity, but this is out of the syllabus. So just know when they just say find the sum to infinity, automatically it's geometric. It doesn't exist for arithmetic. So let's say we have got these two series, and they ask you, does series A converge? So does it converge, meaning does it have a specific limit? So for it to converge, how do you without adding, without doing all those long that long procedure, right? So what you will do is you'll just check the common ratio must be bigger than -1 and smaller than 1. So if the common ratio is between this, it means the series will converge. It has a certain limit. So this just means it must be a negative or a positive proper fraction. So let's check what's the common ratio here. So if I say 4 divided by 2, the common ratio is 2. You see, if you say 8 divided by 4 is also 2, so it has a common ratio of 2. Now 2 is not between this, 2 is bigger than 1. So we already know it does not converge. So you will tell them, you say, no, it does not converge. So you'll say it does not converge. And you have to explain why, right? So you will say because it does not fall, you say it does not fall in this range. So you have to be specific. You'll actually say the ratio does not fall in this range, right? So you'll say the ratio does not, right? So you say the ratio does not fall in this range. So it has to be in this range. When it's in this range, meaning if it's a positive or a negative proper fraction, then it will converge. So because this is bigger than 1, even if it was 1.5, it's still bigger than 1, so it does not fall in this range, so this series does not converge. Now let's check, does series B converge? Well, let's find a common ratio. We found that it was actually r is equals to 1 over 2, right? When we say 1 over 4 divided by 1 over 2, you'll get 1 over 2. So also same thing with 1 over 8 divided by 1 over 4, you'll get 1 over 2. So since our r is 1 over 2, and notice 1 over 2 is a proper fraction, 1 over 2 is actually, so you'll say r, you'll have to tell them r is equals to 1 over 2, then you'll say it converges, right? You'll say the series converges. Why does it converge? It's because 1 over 2 is bigger than -1 and smaller than 1. So don't just say, don't just put this, I see some students doing this. So if it's a 1-mark question, it's good, but if it's not a 1-mark question, if it's a 2-mark question, don't just state this and leave it like that. You can't do that. What you have to do is you have to tell them the ratio, and tell them that the ratio is between this stuff. Alright, so if they ask you does it converge, if it's between this stuff, yes, it converges. If it's not between this stuff, well, it does not converge. So here is another question. So they can give you something like this, and they can say, does the series converge? Or rather not, they can say these are the first three terms of a geometric series, and they can ask you for which values of x that will the series converge. So if they ask it to you that way, if they say which values of x, so it obviously means it's not one answer, it's a range of values. So which values of x does the series converge? Well, the series always converges if r is bigger than -1 and smaller than 1. So what we have to do here is we have to find the common ratio. So we'll find the common ratio by saying this divided by this. So we'll say x minus 8 squared over 2 divided by 2 into x minus 8, right? So when we divide in fractions, we change division into multiplication, and this is the same as over 1, right? So according to the rules of fractions, when we divide, we change to multiplication and we switch the second one, so it becomes 1 over 2x minus 8. So then this becomes x minus 8 squared over 2. So we leave the first one like that, we switch the second one, and we change the division sign into multiplication. So when we have this situation, well, we can just multiply along the same line. So this times 1 is just that, so it's x minus 8 squared, and while it's 2 times 2 here is 4, so times this stuff is going to be 4 times that stuff. So let's not multiply it, or else it will be more complicated. Now here, notice we have x minus 8 squared divided by x minus 8. So here it's like the bases are the same, right? It's just like having a squared over 8a, right? So if the bases are the same, we just subtract the exponent. So it's going to be 2 minus that invisible 1, which is a 1. So it means, so since it's a positive 1, our answer is a as a numerator. So this 8 still remains down. If it was a negative, this a would have gone down, right? So for instance, let's look at another example. Let's just say we have a3 minus a5. So according to laws of exponents, we have to subtract, right? So 3 minus 5 is -2. So you see, instead of it having a positive, it's now a negative. So it means our answer was not going to be like this. It means our answer was going to be, there would be nothing on top, so it would be 1, because there's an invisible 1 on top, right? So we just write that 1. And then it would be over a2, because our answer was -2, so we have to write it down as a positive. This is just one of my methods. There is still another way to deal with it. Another way to deal with it is that you can see this cancels out, and here there's 2 of them, so it will cancel one of them and leave 1, right? It's another way to deal with it, but you can just use laws of exponents and say same base, you subtract the exponents. So here it was x minus 8 squared divided by x minus 8. So you can just say 2 minus 1 is 1. So our answer is x minus 8. Since it was positive, it is a numerator. If it was maybe a negative, maybe if it was -2, we'll have to write it down as a denominator and change that negative into positive. So here we've got 2 minus 1, which is just 1. So our answer is x minus 8. And then here there's 4. So there we have it. So this is our common ratio. So it's x minus 8 over 4. Then once you get your common ratio must be between this, right? It must be bigger than -1 and smaller than 1. So our common ratio was x minus 8 over 4. So that thing must be less than 1, and it must be bigger than -1. So then you solve for x. Well, if you have this situation, whatever you do in the middle, you do it to the left and to the right. So to get rid of the fraction, I'll multiply everything by the lowest common denominator, which is a 4, right? So I will multiply this side by 4, multiply this side by 4, multiply it by 4. And then this 4 will cancel that 4. So it's going to be left x minus 8. 1 times 4 is 4. 4 times -1 is -4. So now we have this. So we want to be left with x alone. So what are we going to do? We're going to take this to the other side, right? So it's going to be left x only. So it's going to be 4 plus 8, because it was a minus. And we also take it to that side as well. Whatever we do to the middle, we do it to the left and right. So this is going to be -4 plus 8. So -4 plus 8, which is 4. and then 4 plus 8 is 12. So this is the answer. So this is the range of values. So x must be any number between 4 and 12. So this is how we deal with it. Because they said for which values of x will the series converge. Whenever you hear converge, we use this rule. So r must be bigger than -1, and at the same time it must be smaller than 1. So we find our r by dividing both sides, and we just substitute it there and we start solving for x. That's what we do. Okay, there's something I have to deal with there. Let's say it was actually this, and it was x minus 8 over 2. Then here it was x, okay, it was squared. Here's x minus 8 over 8. Here it was cubed. Alright, so they can say find the sum to infinity if x is equals to 1. So if they tell you now that x is equals to 1, you just have to substitute 1 everywhere. So if you everywhere there's x, so since x is 1, I'll substitute 1. So 1 minus 8 is minus 7 times 2 is negative 14, plus this is going to be negative 7 squared is 49. 49 divided by 2, so we'll have 49 over 2, plus, and then now here we're going to have minus 7 cubed, which is, I think it's maybe 243, I'm not sure, let me just check it out. Okay, so it's 343, so it's negative 343. Remember, you just substitute x in the calculator, right? The question says find the sum to infinity if x was equals to 1. So because they say this equals to 1, you just substitute x and you find the answer. Then from here you just have to find the common ratio, right? So let me find the common ratio. So if you divide this by this, you will get minus 7 over 4. You also divide this by this, you'll also get minus 7 over 4. So the common ratio is negative 7 over 4. Now be careful when typing this into the calculator. If you say, if you type this, if you say negative 3, okay, I made a mistake here, it's actually negative 343. So if you say negative 343 over 8 divided by 49 over 2, if you type it like this in a calculator, yeah, you'll do well, but you must be careful. You see, the mistake that most people make is that their intention is this. They want to type this in a calculator, but in the calculator, this is the longest line, and it's a different interpretation. So you have to be careful of that. You have to make sure that in the calculator, the middle one is the longest, because it's a fraction divided by a fraction. But if you want to avoid that confusion, you can just type this in the calculator. Just type it like this in the calculator to avoid fractions, rather than to avoid confusions, rather than typing complex fractions. So our common ratio was negative 7 over 4, and our a is negative 14. So we find the sum to infinity. So sum to infinity, it's a over 1 minus r. Our a was negative 14, and we say negative 14 over 1 minus our r was negative 7 over 4. So we have to be careful of that. We have to be careful of that. So our r was negative, so we have a double negative here. So we just type this in the calculator. So we're gonna say negative 14 divided by 1 minus, okay, 1 plus 7 over 4. Double negative gives us a positive. So then we have the sum to infinity, which is negative 56 over, I believe it's 11, and then this in two decimal places is going to be the sum to infinity, which is negative 5,09, right? So there we have it. That's the sum to infinity. So if they ask for the sum to infinity, if x is equals to 1, we just have to substitute 1 wherever we see x, and our pattern will be simplified. Then from here we just find the common ratio, and we know our a. Then we just use the formula of sum to infinity. So that's how we deal with it. If they ask you for which values of x will the series converge, you just have to solve for r by you have to find out what r is by saying this divided by this, or if you want, you can even say this divided by this. It will give you exactly the same answer. Then when you find r, then you put it in that range, right? You say r must be bigger than -1 and smaller than 1. You just plug that answer there and you start solving for x, and then from there you have got your final answer, which is a specific range. So it's telling you that whenever x is that value, the series will converge. So here is another example. For which values of x will the series converge? So you can pause the video and attempt it, and then you can check your mistake. So if there is, hopefully not. So if they give you this and they say for which values of x will the series converge, well, you have to find out what is r. So we'll just say this divided by this, so it's going to be x plus 4 squared over 2 divided by x plus 4. So we're dividing fractions, so here is over 1. So we have to switch. This is x plus 4. This is what they call tip and times, this method. So this is going to be, so we keep the first one like that, and we change the division sign into multiplication. Then when we multiply this stuff, we'll have x plus 4 squared. And then here we'll have 2 times this stuff, so we just keep it like that. So remember, we don't have to distribute. Now since these are the same, we subtract the exponents. So 2 minus 1 is 1. So it means the answer is this thing to the power of 1. So since it's this thing to the power of positive 1, it remains on top. And then what's left down is 2, right? Or if you want, you can say, well, these things are the same. So this thing, x plus 4 into x plus 4 is 1. Then x plus 4 into x plus 4 squared. There's 2 of them, so it will cancel one of them and it will leave 1. So the answer will just be that. So that's what you'll have. So either way, so this is just algebra, right? There's other videos where I deal with this type of things. Alright, so this is algebra. So we got our r, which is x plus 4 over 2, right? So our r was equals to x plus 4 over 2, right? So that was our r. So what you do here, so from here you now say r is between -1 and 1. So you substitute that. So x plus 4 must be between -1 and 1, right? So from here we need to solve for x. So we'll just multiply everything by 2, right? And then this 2 will cancel that 2, right? So to avoid confusion, let me just create some space. So we have x plus 4 over 2, right? So we just have to multiply by 2, multiply by 2, multiply by 2. So this will cancel this, and it will be left x plus 4. And then 1 times 2 is 2. And then 2 times -1 is -2. Then we take this to the other side, so we're gonna be left with x only. So we're gonna have 2 minus 4. So and then on the right side we're gonna have -2 minus 4. So -2 minus 4 is -6, while this 2 minus 4 is -2. So it means x must be anything between -6 and 2. Then the series will converge if it's anything between that. Then the next question, you can pause the video after I state the question. So the next question is find the sum to infinity if x is equals to 2, right? So if x is equals to 2, or rather not 2, because it won't converge, find the sum to infinity if x is equals to 0. So you can pause the video and attempt it. So if x is equals to 0, well, this is going to be 0 plus 4, which is just 4, the first term. Here's going to be 8. Here's going to be 16. So we have a pattern here. And of course, so our common ratio is going to be 8 divided by 4, which is 2, 16 divided by 8, which is 2. So our common ratio is 2. So a is equals to 4 and r is equals to 2. So sum to infinity is a over 1 minus r, so which is a, which was 4, and then 1 minus 2. So that's the sum to infinity. So here 4 over 1 minus 2, so that's gonna be, so it's gonna be -4. So that's our sum to infinity. Right, so yeah, let me just check something. Alright, is yeah. So the next question is, you can pause the video after the next question, right after I state the next question. So the next question is, solve for x if x is equals to, okay, rather find the sum to infinity, right? The next question is find the sum to infinity if x is